So example 4, we're making the table for this piecewise function. And we said 2x plus 1 if x is less than 0, and 2x minus 1 if x is greater than or equal to 0. So at this point, we're going to take a look at graphing these out. And since there are actually two equations here, we know we're going to deal with two tables, sorry. So two equations, two tables. So when we do that in a few minutes, we're going to deal with that. Now, with this, when we actually do our part here, I'm going to do a number line again. And that way we can kind of see what's going on, what numbers are we dealing with. We say the 0's here, and we say that x is going to be less than 0. So that means, are we going to go numbers that are bigger than 0 or less than 0, smaller than 0? Ones are smaller. So these are numbers like -1, -2, -3, -4, so on and so forth. Those numbers. So when we do our table, we're dealing with numbers that are like this. And then also for the next one, it says x is greater than or equal to 0. So it means we start with 0 and then we go up. 1, 2, 3, 4. The positive direction. And for some reason, that's the biggest part that people mess up on, is knowing what numbers to put in the table. Okay, so with that, let's go ahead and pull these out. We make our two tables. Now, with that, we made two tables, and we put the equation of the first one on top of the first table. So this one comes here, this one comes here. So that means also, let's go and pull in our inequalities. So we pull both of those in, and those tell us what numbers go for x, because it says x is less than 0. So those numbers are going to be here. But again, always start with the end point. So always start with the end point. Always, whenever you start doing their x values. So here we start off with 0. That's our end point. And we said their numbers that are going to be less than 0. So that means we're going to deal with -1, -2, -3, -4, so on and so forth. But here, all you have to do, like with these that go on forever, all you have to do is at least have 5 numbers and you're good. You don't have to do anything else. All right, for this other one, and again, let me just show you this part too, because I like drawing this part here. So all the x values are coming from here. From x is less than 0. And then here, x is greater than 0, all the x values are going to go in here. And again, always start with the end point. Always start with the end point. So here, we're going to start with 0, and we're going to go up to positive. So 1, 2, 3, 4. And again, you can go past 4 if you want to, but you need to at least have 5. At least 5 numbers. Okay, so we have all that going on. And now the next part is substituting these values into the equation. That goes in for x, that goes in for x, that goes in x, that, and that. If you want to put it in a calculator, you can do that too. You can put 0 in for x here and then solve it out. You can put -1 in for x and solve it out, so on and so forth. We've done that enough times, I think, now that we don't really have to, I don't have to show that again. But if we put 0 in for x right here, that'd be 2 times 0, which is 0, plus 1, which is 1. Put -1 in for x here. 2 times -1 is -2, plus 1 is -1. Then -2 we put in there. 2 times -2 plus 1 gives me -3. And -5 and -7. And again, you can put that in the calculator. And all we're doing is taking these values and substituting in for x. And find your f of x value and put it in there. Alright, and this one is the same way. We put a 0 in for x here, put a 1 in for x, a 2 in for x, 3 in for x, 4 in for x, and we solve it out. So we put 2 times 0 is 0, minus 1 is negative 1 again. 2 times 1, so we start with the 1 part. So 2 times 1 is 2, minus 1 is 1. And then 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. And then 2 times 4 is 8, minus 1, and that's 7. Okay, so that filling our table. That filling the table shouldn't be that hard. I hope not. I really hope it's not that hard. It shouldn't be something that's really strenuous and arduous and everything. Something that you can be able to do really quick. Now, with this, we're not done with the table yet. We're going to do something on this part right here. That's why I left the space there. We're going to do something there for this next part. This next and last part. Alright, so let's go and take a look at it. We're going to talk about something that we did when we did interval notation. We talked about open and closed circles. That's going to come back into play now. Yay! Open and closed circles. So, let's take a look at this. Open and closed circles. Now, when it comes to this part, we're talking about our endpoints. We're talking about whether they're going to be open or closed and what's going to happen with the other stuff. Now, we're going to talk about the endpoints first off by themselves. So, endpoints. Now, again with the endpoint, these are the ends of the inequalities. So these are the ends of the inequalities. So for example, if we look at it, I'm going to give you some examples so you know what I'm talking about, not just say, well, just do it. Let's say we have these here, these inequalities. If we were to look at these inequalities here, you should see that for this first one here, the end point is 0, right? That's where it starts at 0, that's where it ends, and then it goes on forever and ever and ever. Because we know if we graph this out really quickly, we would have 0 here, and then we would shade all up here, and then it means it's going forever, right? So it starts here, and then it goes on forever. So it's kind of like the end point, or starting point, whichever one you call it. Right, for this next one here, 0 is the end point again also, isn't it? Because it starts at 0 and it goes down forever and ever and ever. Like when we do our number lines again, shade it. Goes on forever and ever and ever. So it's like an end point. And then here, there's actually 2 endpoints. So the endpoints here are -2 and 4. So they're both of them, -2 and 4, because it starts at -2 and ends at 4. And we know that because when we graphed this out on a number line before, like when we did our interval notation, that's what we did. We started at one spot and we ended the other spot. And we had our brackets and our parentheses and stuff to go with them, right? Okay. Now, those brackets and parentheses parts is going to be coming back in handy because that's what's going to help us to know whether we're dealing with open and closed circles for these endpoints. Now, again, for the endpoints, and I'll write this down. Let me write down in, let's do it in blue. Let's do it in blue. So for our endpoints, they're the only points. So the endpoints are the only points that can be, an open or closed circle. That's the only one that can be open or closed. All the other points after that endpoint or in between the endpoints, and let me write this down too because that's important. Every point after the endpoint or every point between the endpoints and here, let me give you a quick example of both of these. So ones that are after are the inequalities that look something like this. And the ones that are betweens look like this. So remember we talked about betweens. So anything that looks something like those. So every point after these endpoints or every point between these endpoints are all going to be closed circles. They're all going to be closed circles. So here, the only thing that we have to do is figure out what the endpoints are. Because everything else is going to be closed circles. The endpoints are the things that we have to figure out whether they're open or closed. And it all depends on the inequality. So with these, let's go back here again. And I know, guys, this is a lot of information right here, but we're about to be done with it because this is pretty much where it ends. You know, here, this part here, that's just a less than sign. So that means it's going to be an open circle. That means open circle at 0. And again, here, that means it's going to be a closed circle at 0. But then on these two here, there's two separate ones. So it's closed, a closed circle, sorry, at -2, and open circle at x equals 4, or at 4. And so here, this one goes to that one, and this one comes here. And you just got to remember when you have open and closed circles and what they mean. So here, going back to our table really quickly, we said that for this one here, because it has just a less than sign, just less than, it means this is going to be an open circle. And then anything after that is going to be closed. Any point after that is closed. So only the end point can be an open or closed. Everything else is closed. All right, so for this one here, that end point has an equal to sign on it, so that means it's closed. And again, after that end point, everything else is closed. So the only thing you have to figure out is that end point. Everything else is going to be closed. You have to figure out the end point, and everything else is closed. So that's all it is. You figure out whether the endpoint is open or closed, and everything else behind that is going to be closed. And that's it. So please don't make too much fuss into this to make it too hard. It's either it's open or it's closed for the endpoint. Everything else is closed. And that's all you got to do for the table. And again, there was a lot of information here, so you don't have to do all the information for every table. Just make the table, fill in the values in, tell me whether they're open or closed. And then you're done.